Hello everyone, hope you are fine. Today I am going to discuss the exploratory data analysis of the Pakistan class side class data. So here I have the code that data set which I have taken from the Codexco site. So Codexco provides me this data. Done some EDA and some analysis on this data and explore this data set side from article data. So first of all, I have import some libraries which is Spark data exploration. So here is the code. Then install pandas. This is the code for installing the final libraries, and then I have imported their library SPD. That is a universal standard. So I have used that standard that panda is imported as PD. Okay. Then I have installed the C1 library for visualization purposes, which is SMS. Similarly, I have installed Matplotlib library, and that Matplotlib I have called the PyPlotter as a PLT. So this is also used for visualization purpose or some bigger size purposes. So I have imported these libraries. Now I have copied the path of this function, this data, and then tell the pandas library to read this CSV file and giving the path of that file. I mean the suicide bombing attack CSV file path is copied here. Okay, and I have given the name SDA, suicide data, suicide bombing data. So this is named as SDA. Now I have put the function here to show us the head of the dataset. So sda.head, that go to the SDA dataset and show me the header, and 2 as an argument which I have passed here. So here as this will show us the first 2 rows of the dataset, and you see that this is the first 2 rows of the dataset, and the above are showcasing the above headline showcasing the columns name. So here is time column, city column, longitude, latitude, province, holiday type, last day type, and so on up to temperature. Temperature final. Okay. So temperature Fahrenheit and temperature is centigrade. So hospital name is also given. Explosive weight. These are the column names. Then I have passed in function that show me the description of data, and it means that show me and describe me the data set. What is its mean, median, count, and standard deviation, percentile, quantile, and median. So these types of data is given here. Okay. So it means that child minimum, child maximum, and child maximum we have 9 and 8 rows given. Okay, count is this much. Then the mean of the child maximum is 15. The standard deviation is 19, and when we take the square of standard deviation, it will give us the variance. This is some measure of dispersion. So I will discuss as further in the later on videos. So the minimum is 0, and the maximum is here. The maximum is 148. So it means that and blasting attack, suicide blasting attack, the maximum cal was 148, and the minimum cal was no cal, so 0. Okay. Now moving to the next step. So as I have mentioned about that, we have head function. Similarly, we have here tail function. It will show us the last 2 rows of the dataset. So these are the last 2 rows of the dataset. Here you will see the none. and none here, also none here, here, and target none here, none here. It means that these values are missing. So we have also the missing data present in the data set. So for exploring this data more much, we have pass in function that go to the SDA file, which is suicide bombing attack here, and show me information of this file. So it showcasing us further information that range index, that total entries is 988. It means that this much rows are present here in the data. So and the total columns, data columns are 25. It also include columns which are not necessary, but the data in the data, those columns are present. So to pass this data to some machine learning algorithms or some machine learning models, we have to clean it and drop those columns which are not necessary for that machine learning models. Okay, so here is that column, and that column we have 988 values and none of null values. Okay, so similarly we have and that none, it means that in 988 values we have none of null values, and the total entries are 988. It means that this data set, this data column is full of data. It means that no missing value is present in it. And Islamic date we have 678 values given in it. So and 678 values which are present in the Islamic date column, and this count and 678 values we have none null values. It means that this much rows are not null, and some of null values are also present. We will get this value by simply subtracting this value 678 from 988. So we will get the null values, the null rows values. Okay, and it also showcasing the type of data sets. These you can see that that is object data type, the latitude is plot data type, and so on. Okay, similarly it also gives us the count. We have a simple function that is the count. Can you go it means that go to data set and count, show us the rows, number of rows present in each column. So it also showcasing the same result as mentioned above. Okay, so for the shape of data I have just to put a function sda.shape that go to data and give the shape of data, and for the types of data we have that d types function which is also mentioned above. If we are interested to take information about a specific column in the dataset, so here is a function that go to SDA, go to the dataset, and that dataset tell me about the province. I have passed a column here, provinces. So in dataset we have a province column here. I will show it to you. This you see that this is a province column. So here is a province column in the dataset. So I am interested to get information about this specific column. So I have passed that column name, and then I told the Python that describe it to me. That describe will show us that what is the summary of that column. So in this column we have a total count of 988, and unique values are 9, in which top, yeah, it means that the most repeated values is kpk, and frequency of this kpk is 501. It means that in the dataset kpk is repeated more than any one entry of in the province column. So kpk is the mode of this column. Okay, and the type of this dataset is object data type, and the name of the column is province. Similarly, I have passed another another plotting type of column to showcasing us all of the data and all of the aspect of the data of that column. Okay, so I have simply put in that column name and pass a function that describes this to me. So the count of this column is it means that how much rows are there in this column. So 8 to 4 rows are present in this column. Mean of this column is 1.116505. Standard deviation is this, minimum is this, and the maximum is 4. The column name is this, and this is a plotted 64 or plot values column. Okay. Similarly, I have applied this function on more columns to get an idea. Okay, so here you see that I have some duplicated values which may present in the data. So here you see that s duplicated s dup equal to sda dot duplicated, and number of duplicated rows. I have defined sdup function as it is duplicated rows in the dataset. So here is the number of duplicated rows in which 466 entries or 466 rows are duplicated. So I have dropped those duplicated rows. Before dropping the duplicated rows, the shape of the data is this. After dropping the duplicated rows, this is the drop function which is used to drop the duplicated rows. sda.drop duplicates from the dataset. Okay, so sda.shape will show us the result of the result the shape of the data, not including the duplicated rows, because we have already applied the duplicated rows function here. So now after removing the duplicated rows, it will remove the duplicated rows, but in in the dataset we have some null values present. You see that I have just apply as null function and then pass an argument that show me the sum of that null values present in the dataset after removing the duplicate rows. Okay, so in that we have 0 entries which are which is null, and Islamic date we have 174 values which is null. It means that huge amount of data is null here. Similarly, in holiday type we have huge amount of data which is null. Null means that none values is present in the dataset. I have told you in first 5 minutes. You see here this. This is a null value. This none showcases us null value. Okay. Now moving further. Okay, here you see the explosive where you have 3, 4, 6 null values. Similarly, to showcase the null values in a heat map, we have this function that go to C1 library. I have showcased this C1 as SNS and draw me the heat map, and heat map will include the SDA. It means that go to the SDA dataset, which is suicide bombing attack, and show me the null values and why false. This is an argument which I have passed to, and this is also a function which I have passed to showcase us. This will showcase us the overall heat map, and then I have called another library which is used for tabulation purposes, matplotlib. So go to matplotlib, and the title name I uh, I I am recommending here that you should put the title as a missing data on the top and show us the plt show it means they show us the table or they show us the plot. Here you see that the missing data is on the top because it is a title name, and the entries within each column. Here you see these are the column names, and that we have zero null values. Islamic date we have some amount of null values, and this holiday type contain large amount of null values. The green dots or the green line will show us the null values, and the gray color will show us the values which are present in the column. So here you see that in province column we have zero null values. Similarly, in location category column we have zero null values, and location sensitivity column we have zero null values, and temperature we have some values, and killed maximum have zero null values. Okay, injured minimum have some values which uh, which is null, and injured maximum have less values which is null. So we are we will exclude those columns which have large amount of null values because they are useless. Now, to drop a column from the above data sheet, it is a lengthy process because we have large amount of column, and we are interested in the column which benefits our machine learning algorithm or which are necessary here. So at SDA, I I have taken some column and name is final SDA or FSDA. Okay, so I have selected that final SDA is equal to SDA. Go to dataset SDA and merge those columns: date column, city column, province column, location, category, location sensitivity, kill maximum, injured maximum, number of suicide blast, target type. These are the column which is the most important column, which are the most important column in the dataset. So I have named this dataset. This will give us a new dataset which name is FSDA. So the head of FSDA is, here you see the head of FSDA is this: date, city, province, location sensitivity, target, kill maximum, injured maximum, number of suicide blasts. So this is the important data which we have separated from the above dataset and name it FSDA. So here is the here I have drawn some map to showcase the null values and the final dataset column. So FSDA, it means that go and SNS gave us heat map based on FSDA and show us the null values. Okay, and I have passed the title that missing data of FSDA. So you see the title missing data of FSDA. Now you see that we have a less amount of data which is uh, null or which is none values present in the column, specific column. Okay, here you see that and number of suicide block. Last we have large amount of data which is null. So I am interested in the dash column, number of suicide block last. So I want to describe I explore more this column. So I put in a function that describe it to me. So the count of this is this much. The count of this column, it means that in number of suicide loss we have 4 to 5 rows. The mean of this data is 1.11, and the standard deviation is this, minimum is this, maximum is this. Okay, and the type of data is plot. Okay, so I want to replace this missing value with the mean of this data, this column. So for this I have put a function which is FDA, that in FSDA in final data sheet, and in final data sheet go to the number of suicide lost and fill null with their mean value, which is 1.117647. This is the mean value, so I have copied this values and pasted it here. So it will replace the none values with this value. Okay, and it's showcasing me that the value is replaced by 1.117. Okay, now the effect is the count is this much, the mean is this. This is after applying the mean function that replaces the entries which is none with the mean. Okay, I'm going further. Let me apply this function first. Okay, I have applied this. Okay, then here applying this function. Now you see that, sorry, little bit mistake here. Okay, so those data is replaced by the mean. Okay, now I am interested in the integer max, so here I want to describe that function. So the count is this much, the number of rows is this, unique rows is this, top is 2. It means that 2 has maximum frequency here, so it is the mood of the data. Okay, and the count is also given here. Okay, so after replacing the null values of the number of blast, we have also some entries present here. Here in this data, this null values is replaced by the mean values of this column. So we have some null values present also in the others column, but they are so less in count, so we will remove this by the drop null function or drop na function. Let me show you. Here is the function drop na. Here, that go to the final data set and drop the null values, this for which drop na function is used, and in place 2. Okay, so it will remove all the null values from the data set. So the final data set will be at so after removing all the null values, I have drawn some heat map. So I have told the SNS to draw the heat map, and all the other things is same as I mentioned above. So here is the missing data of SDA. So no value is missing now. You see no blue line here. So the data is full with entries, and no missing values are present in the data set, and no duplicates values also. Okay, now I am interested to see the values and describe it, and describe the function that tell me about the dataset, the final FTA dataset. So here is the number of counts of CalMax, the mean of this, the standard deviation, and similarly we have number of suicide blast, which is also 401 entries here. So this is also given that the mean is this, the minimum is this, the maximum is this much. Okay, if you here click on this icon you see here, so it will suggest you some charts, so which is given below it, these charts, but we will draw it on our own. Okay, now after applying all the necessities and necessaries function, so I am interested to see what are the null values present, if any. So we will remove it, but I am 100% sure that no values will be present. But here for your current information, I have passed this function to see if any values is missing, we will replace it or remove it. Okay, so FSDA go to final data set and apply the function information that give me information about this specific data. So here you see that the pandas have applied this index. It means that the total number of entries is 401. Okay, so here the total number of column in the final data sheet is 10. Okay. In that column we have all the values same here. In that data sheet, in this data sheet, we have all the values same here. You see 401 here, 401 here, up to the last, and none of null values is present here. And we have data types, float, two data types, floating points, which is two data types, and object is 8. Okay. So after removing all the missing values and duplicate values and cleaning after cleaning the data, we are interested in visualization of that data sheet. So I have passed in function that go to the plot. Okay, here is a function that I told the matplotlib that give me a figure of size 30 and 3, that means that 30 wide and 3 inches or 3 centimeter and width and 30 centimeter and length. Okay, so I am interested in bar plot to see the target type, that what target type have maximum cal. So I have put the target type on x-axis and cal maximum on y-axis, and give them the data that that tell me this about this two column from the data FSDA, and tell the matplotlib library to show us the result. Okay, so the result is this. You see that and corner we have a tag in which the kill function is around about 15 to 20, I think some 17 number. So the in corner in this attacks this much corner are killed. Okay, and media, in media we have some round about 5 or 3 members killed. So the killed person, the killed max is round about 3. Okay, and religious sector or target type we have some amount like 20 or 25. Okay, this much people are killed. And military we have some number like 10 to 15 which is killed here. And you see here Shia sect. Shia sect we have most number killed here, round about 80 or 70 to 80 members are killed. Okay, so it will showcasing us the uh, the killed person as for the target type. Okay, now we have another visualization. I am interested to see that show me the bar plot of the province with kill type, that which province have maximum killed and which province have minimum killed. Okay, so in capital we have uh, the killed person as per the data is around about 20 or 21 something, and since we have the number is raised up to, I think here is 30, round about 30 people are killed here. So in Balochistan we have maximum killed, and Pata we have some amount which is below the Balochistan. This number is killed. In KPK we have moderate number of killed, round about 25 to 30. Okay, it will show us the mean of that data set. It means that in the data set we have a capital category within province. Okay, so in province we have a category named as capital, and that capital category we have values, so it will showcase the mean values of that data. Okay, now the head I am interested to see the head after doing some after applying some function, so it is the head of the that. And now if I am interested to see the some outlier, detect outlier, and get the 5 number summary. This 5 number summary is the minimum, maximum, the Q1 which is quartile first, the Q quartile first, and the Q2 will showcasing us the median, and the Q3 will showcasing us the 75th value or quartile third. Okay, and it also showcasing us the outlier. So I have passed a function that told the SNS to plot a box plot. A box plot will show us a summary, a 5 number summary. Okay, and I have passed the column kill maximum. That in kill maximum, how much outlier represents. So here is the result that the minimum is around about 0. Okay, the minimum value is 0, and the median is round about I think here we have like 9 or 8 or 10. 10 is the median I think, and the first quartile is round about at the place round about 3 or 4. 3. I think 3 is the first quartile, and the second quartile, the third quartile is round about 19 to or 20 in this range. Okay, and the maximum of this data will be 42 or something. Okay, and these are some outlier. One outlier is huge because it is near to 150 or 145. Okay, it also shows us the interquartile range. Interquartile range is the area which contains 50% of data, which is from Q2 to Q3. This blue range presents us the interquartile range. Similarly, I have drawn this function, this plot for the entered maximum, and here is another plot. Here there is another plot which showcasing us the bar plot. Okay, bar plot of location sensitivity and the kill function, the kill maximum. That based on the location sensitivity, how much person are killed. Okay, based on location sensitivity, how much person are killed. Go to SNS, plot a bar plot. X will be the location sensitivity from the FSDA dataset, and Y will be the kill maximum from the FSDA, this dataset. Okay, so it will show us this plot. On x-axis we have location sensitivity, on y-axis we have Calmax. Okay, where the sensitivity is high and location sensitivity, we have three subcategories. The one is high, the one is low, and the other is medium. Okay, and Calmax we have the people which have been held and these blasts attacked. Okay, where the sensitivity is high, the number of killed person is less because they have taken some measuring action, some measures to reduce the kills, and I think they have they have taken some steps. Okay, to secure themselves from the blast. Okay, uh, many argument is passed here that someone told that this will happen, this is the result of this happening, and this is the result of this happening. But the data showcasing us and that the location where the sensitivity is high, the killing number is less. Where the sensitivity is low, the killing number is moderate, and where the sensitivity is medium, the killing number is high. Okay, it means that the number of killed person is high when the sensitivity is medium. Now going further, in this visualization we will get to the bar plot of location category. Okay, that how much people are killed as per the category. We have passed the location category to x-axis and the kill max or the killing of people to y-axis. Okay, so I have just explained it. Firstly, that for which are killed is around about 20 to 25. I think 10 to 20. Sorry, 10 to 20 numbers. Okay, office diligence are round about 10. No, sorry, round about 5. And this showcasing the result that in a highway we have killed person round about 5. Okay, this data will show us the killing of person or the kill makes as per location category. We have the number of category high or much in number, so we have passed the bigger size to 30 centimeter long and width 3 centimeter width. Okay. Now I am interested to see that max column distribution, that how it is distributed and how the data is distributed. So I told the SNS to plot a distribution plot from the data, from this data go to the data set and this from and give me the result of this column. Okay, so it's showcasing me the result like this, that the data is distributed and positive skewed way. Okay, so you see that the data is skewed to positive side, so we can say at the positive skewed data. Okay, now I am interested to see the blast, the number of blast distribution. So here is the number of blast distribution. Okay, which is also positively skewed. Okay, now I am interested to plot the count plot to show us that how much number of blast has been done till now. Okay, so as per the data, if we have one blast at a time, the happening of this one blast is round about 370, round about 370. Okay, or some number here. The when the blast number of blasts is 2 at same time, and the happening of this that number of blasts at the same time is around about 30, yes, 30 or 25, and the happening of 3 blasts one time is near to 3 or 2. Okay, and the happening of 4 blasts at same time is round about 1. Okay, we have one blast which have 4 attacks at same time. It's too hard. Okay, I am interested to see that the number of blasts SG relation exists with the number of blasts with kill maximum, that when the number of blasts is high, then maximum people are killed. Okay, so to see this, we have heat map to see us, and I told that heat map to display correlation on heat map, and YL indicate that that the map will be in color, where YL indicate the most negative correlation. Okay, this is a color, yellow color. Okay, the green will be 0 and the blue will tell us about the highest or the most positive correlation. Okay, you see here the yellow indicates the negative and this indicates the positive. Okay, correlation. Sorry, the yellow indicates the 0 and it will going on to blue. Okay. Here you see that the number of suicide blast and the killing max have a positive correlation 0.31. Okay, this indicates that uh, weak correlation exists between these two columns. Okay, these columns. If the number of suicide blast is high, so it may suggest us that the number of killing maximum people will also high. But this correlation is weak, so we cannot tell this that this is a significant relationship, so we cannot pass an argument based on the number of suicide blasts. Here we have another visualization that show me show me the bar plot via province. We have passed to an argument that x will uh, province is plot on x-axis, and on y-axis we have the child maximum numbers and hue as location sensitivity. So it will show us the graph like this. Here you see that in location sensitivity column we have three categories: high, low, and medium. On y-axis we have the child function, the child column, okay, and x-axis we have the province. You see here that in capital, where the sensitivity is high, the number of child is minimum. This where the sensitivity is low, the number of kill is moderate, and where the sensitivity is medium, the number of kill is high as per the other two. Okay. And since we have when the sensitivity is high, the number of kill is more. Where the sensitivity is low, the number of kill is less, and the sensitivity where is at medium, the number of kill is medium. Similarly, like in KPK, we have the sensitivity less. Sorry, the sensitivity when the sensitivity is high, the number of kill is minimum. When the sensitivity is low, the number of kill is moderate, and when the sensitivity is medium, the number of kill is huge. Okay. Now going further, this plot, this bar plot will show us that on x-axis we have province, and y-axis we have number of blasts, and here we have location sensitivity. That means that how much blast occur as per the sensitivity and as per the province. You see that in KPK here, in KPK, where the sensitivity is high, the number of blasts is high. Okay, the number of blasts are high. Where the sensitivity is low, the number of blasts is less as compared to the other two. And where the sensitivity is medium, the number of blasts is high as per the other two. And Azad Jammu Kashmir, the number is same. Now going further, we have this plot. This is the most important plot. And x-axis, I have drawn some bar plot here. On x-axis, I have put the column province here, and on y-axis, I have put the number of blasts happened. Okay, so now see it that and capital. In capital, here you see that in Balochistan, the number of blasts is the most high. In Balochistan, the number of blasts is maximum. In FATA, the number of blasts is maximum. And Azad Jammu Kashmir, it is too low as compared to the others. And KPK, the number of blasts is moderate. Okay. In Punjab, this is also moderate. So this is the overall summary of the data. Okay. I have drawn another column, another plot which showcasing us the bar plot of province we are killed maximum, that how much people are killed as per province, and which province the number of killed is high, so it will display that result. You see here that in Balochistan, most of the people is killed. Most of the people here, which is around about 25, which is the mean value of this Balochistan category. It means that in province we have category round about 9 category, and province column is divided into 9 category, and which Balochistan is a category where entries where there is lots of entries. So the mean of date entries is around about 26 or 27. Okay. So this will be this is the high number, so it will indicate that the number of killed in Balochistan is high. Okay. Similarly, in KPK it is moderate, and Singh it is also high, and capital it is also near to 11 or 12. Okay. And Azad Jammu Kashmir, the number of killed person as per the suicide blast is minimum. So this is the overall exploratory data analysis of the data. Uh, I hope you will get an idea that how to explore the dataset using these three libraries. Another library is also there, which is name is NumPy, but we will discuss that in the next videos. And this is the overall idea of this dataset. Apologies if I have done any mistakes because it is the beginning. And next we will explore some other data set and do exploratory data analysis of others, and then we will jump into the machine learning algorithms and how we can probe this data on making chunks and then apply it to the machine learning models. Okay, but now in this section in next 5 to 6 videos we will discuss the exploratory data analysis, and then we will jump to that section. And thanks for watching.